What's up guys, welcome back to the channel. Today on this video we'll be doing this question paper, but specifically we're going to be focusing on question 2 of this question paper. Just in case you haven't watched question 1 of this question paper, you can go to the description. I left the video there that contains question 1, so go and watch that video, and the very same video will pop up at the top right of this video that you're watching. Just in case you don't know what question paper is this one, this is a common question paper for mathematics N4, which was written by these two provinces, Gauteng and Free State. So this question was written on the 12th March 2026, and it took about 2 hours to be written. Now, before we continue with question 2, I'd just like to say thank you very much, guys, for watching, subscribing to the channel, commenting, and not forgetting those who like and share the videos. Alright, guys, let's look at question 2 and let's solve it. Alright, let's look at question 2 here. Now, question 2, it's based on graphs. So they want us to sketch these graphs that you see here. As you can see, question 2 consists of 4 questions with sub-questions there. All in all, this actually consists of 8 questions. So we're going to solve question 2, starting with question 2.1.1 until to question 2.4.2. All right, guys. So let's start with question 2.1.1 and let's create space and solve it. Here is our question 2.1.1. Now the question here, they want us to sketch the graph of y is equaling to cot, and then they give us the restriction there. Here is our restriction here. It goes like this: x cannot be equaling to or greater than negative pi, and also x cannot be equaling to or less than pi there. So that is our restriction. So you need to know what exactly is pi in this case. Just in case you do not know what pi is, in this case pi is actually radians. So we have to change radians into degrees so that we can work with something that we are familiar with. So in order for us to change pi into degrees, here's what you have to do. You multiply pi with 180 divided by pi. This here, guys, it's how you change from rads to degrees. Meaning now, pi over pi is going to give you 1 multiplied by 180. So this means pi is 180. Meaning now, negative pi is equaling to negative 180. So our restriction is from negative 180 to positive 180. So I'm going to use a red color to indicate this in degrees. So we can say negative 180, and then here we can say positive 180. Now let's continue. Let's look at this graph here. Now they want us to draw the chord graph. So in order for you to draw the chord graph, there are a few things that you need to know. We need to find the period, and also you need to find the intervals. So let's start by finding the period. Now there's this formula here that we use to calculate the period for the graph of tan and chord. It goes like this: period is equaling to 180 divided by b. Now if you're wondering what is b, b is a coefficient of x. As you can see here, we have y is equaling to cot x, right? So the coefficient of x is actually 1 there. So in this case, b is actually 1. So when we calculate for a period, it's going to be 180 divided by 1. So one full cycle is going to happen within 180 degrees. There we go. And then from there, we need to calculate the intervals. So this is the formula for tan and also cot to calculate the interval. So it's period divided by 2. So we already established that our period is going to be 180, and then 2, we divide by 2 there. So 180 divided by 2, that is going to give us 90 degrees. This means that from one point to another, we move by 90 degrees. So let me first draw the Cartesian plane so that we can draw our graph. All right, so here is our Cartesian plane. Before we continue, let's not forget that we have x here and we also have y there. All right, so let's start. So from the 0, 0 point, we have to understand that this is a chord graph. So with a chord graph from the 0, 0 point, this here is going to be the asymptote line. So I'm going to draw using this red line here, right? and then to the next point. Remember, we are moving with 90 degrees. At this point here, it's where we're gonna intersect, and then the next point is gonna be 180. So this is gonna be asymptote line. That's it. So we stop at 180 because our restriction state that x cannot be greater than 180. It can also be equaling to 180. So that's where it ends then. So when you move to the negative side, at negative 90, we intersect. Remember, we're moving by 90. So the next point again is going to be negative 180. So what do we do then? We asymptote. This is an asymptote line. So I hope you guys know about this, how to draw the chord graph or tan graph. It's very similar. What happens is that we have the asymptote line, and then we have the intersection for chord, and then asymptote line on the next point, and so on and so on. Because our restriction is from negative 180 to 180, so we cannot go beyond these 2 points. So from here, we start drawing our graph. So our chord graph, it is not like tan graph. From the point of intersection, you must move towards 0 point from the positive side of y, right? On the negative side of x, you're moving away from 0. Then you asymptote there. Okay, you must asymptote on the asymptote line. On the negative side of y, we are moving towards 0 underneath them, and also we asymptote on that point there. And also on this side here, on the positive side of x, we are moving away from 0 when we draw our graph underneath there, and then it asymptotes there. So this one here is actually our chord graph. So you can name this graph here y is equaling to cot x, and that's it. So this is the type of a graph that they were looking for, guys. I hope you know how to draw this graph. I haven't made videos on how to draw these trigonometric graphs, but when I have time, I will do videos on them. But this is basically how you draw this chord graph here. Now that we are done with this question, I hope you managed to understand, guys. If you did not understand, please leave a comment on the comment section. And also, if you manage to understand, don't forget to like, share, comment, and subscribe to the channel. Let's move to the next question, which is 2.1.2. Now let's look at 2.1.2. Here is our 2.1.2 there. Now let's read the statement and let's solve this question here. The question goes like this: at which point, if any, is y is equaling to cot x? And then they give us the restriction there, which x is equaling to or greater than negative pi, or equaling to or less than pi. We can also say it in this manner: x is equaling to or greater than negative 180, and x is equaling to or less than 180. They want to know at which point our function y is equaling to cot x is going to be discontinuous. In order for us to find that, we need to do the following. We know that cot is cos x divided by sine x, right? This here is what we call the quotient identities. When we use this, we have to equate our denominator, which is sine x, with 0 and solve for x. So let's do it. So if we say sine x is equaling to 0, x is going to be arc sine 0. Arc sine is when you take sine to the other side there, guys. And then x is going to be 0. But this is not the only point. This is one of the points. The other point, it's supposed to be 180 minus 0 and negative 180 plus 0. So this means that this is going to be 180 and negative 180. Remember, for a function to be discontinuous, it should be divided by 0 when you substitute them. So we are actually dealing with sine there. If we substitute x there, which is 0, this is going to give us 0 there. Also, if we substitute 180 there, that is going to give us 0. Also, if we substitute negative 180 there, that is going to give us 0 there. So at this 3 points here, where x is 0 and 180 and negative 180, these are the points where our function is going to be discontinuous. Guys, I hope you understand this. This is actually N5 work. So this question was actually not part of the syllabus for N4s, but just in case you wanted to know the answers, these are the answer for this question. Guys, I hope you managed to understand this one as well. If you do not understand, don't worry much about it, because this is actually N5 work. But you can leave a comment on the comment section, and I'll try to explain to you to my level best. But if this helped you to understand, do not forget to like, share, comment, and subscribe to the channel. Alright guys, we are done with 2.1. Let's look at 2.2. Alright guys, let's look at 2.2. Now 2.2, it has two questions here. We have 2.2.1 and 2.2.2. So 2.2.1, they want us to sketch the graph of y is equal to 2 multiplied by 3 to the power of 2x. This here, guys, is an exponential graph. How do you know? Because x is the exponent there, just in case you can't figure it out, right? So the exponential graph, guys, in order for you to draw it, I always recommend that you use the table, even though they do not mark the table, but it's easier that way. So let me first create a table, and then let's draw our graph. All right, so let's look at the x entries then. As you can see, I have -1 and -0.5, and then 0, 0.5, and +1. These entries, guys, they are actually your choice. I prefer that we use the smallest number when we insert the x values there, because if you use the bigger numbers, you might get a very huge graph, guys. So the best way is to use the entries that are very small when it comes to numbers. So I hope you guys can able to understand that. So let's start. If x is -1, what is going to be our y? Now if we write our y there, it's going to be 0.2 there, right? Yeah, rather leave it in a decimal point so that we can able to draw it on our graph. Now let's look at the next point there. When x is actually -0.5, what is going to be our y there? Our y is going to be +0.7. So 0.7, that is going to be our y. Then when our x is actually 0, what's going to be our y there? So our y is going to be actually 2. There we go. Now when our x is actually 0.5, what's going to be our y? Our y is going to be 6 there. And then when x is actually 1, what is going to be our y? Now if we put that on a calculator, it's going to give us 18. As you can see, people, the reason why I said you must insert less or small numbers on x is because the bigger number will increase our y. As you can see, as we move to positive, our y becomes bigger from 2 to 6, from 6 to 18. That is exponential growth there. So if you put bigger numbers there, it's going to be way too big. So from here, let's draw our Cartesian plane, and then we can able to draw our graph. All right, so as you can see, here's our Cartesian plane, guys. Now if you can look at y, we have the multiple of 6, and for x we have the multiple of 0.5. So it doesn't really matter that much how you do your multiple, but make sure that you don't make your graph to be big, guys, right? So let's start at this point here. When x is -1, our y is going to be 0.2. So we know that x is -1 here. You take a ruler, you draw a line, and then our y is supposed to be 0.2. 0.2 is very close to 0, so you can just draw a line here very close to 0, and then wherever they meet, that here is your point there. Now let's move to the second point. When x is -0.5, our y is going to be 0.7. Again, -0.5, it's here. You draw a line here using your ruler, right? And then y is supposed to be 0.7. 0.7 should be a little bit up here. Now draw a line from there, and then wherever they meet, this here is going to be your point. Now let's look at point here when x is 0 or y is going to be 2. So we can say 2 it's somewhere there, guys, right? So when x is 0 or y is 2, let's say 2 is right there, right? And then let's look at the point where our x is 0 comma 5, our y is supposed to be 6. So 0 comma 5 is this one here. Let's go. And then 6 is supposed to be that one there. That's where they actually meet. And then the last point, when our x is 1, you draw a line there. Our y is supposed to be 18 there. There we go. This is the point there. Point there. Then you start connecting. Guys, it doesn't really matter these points that much. What matters is the shape and the y-intercept. Guys, this is our graph here. What matters is the shape and this intercept here, the y-intercept. So always write it 0 and 2. Make sure that you write it, especially if you don't have 2 on this one there. Write it on the side like this. All right. And then the shape as well is the one that matters the most. So we can say y is equaling to 2 multiplied by 3 to the power of 2x. So this here is our graph. Guys, I hope you managed to understand this. Like I said earlier, the x entries, you don't have to put big numbers. Just put the smallest numbers that you can think of. And also you can start from negative to positive part of the number that you started with, right? And all you have to do is substitute, you get your y values, and then you plot your graph using the points that you just gotten there. All right, people, I hope you understand this. If you do not understand, you can always leave a comment on the comment section and rewatch the point that you did not understand. And you can always like the video, share the video, subscribe to the channel if this helped you to understand how to draw the exponent graph. Okay, people, we are done with 2.2.1. Let's look at 2.2.2. Now, 2.2.2, it's 1 mark. They are asking this question here. Is y equaling to 2 multiplied by 3 to the power of 2x a function? Now, the answer here is yes, it is a function. How do you know? There is one method that you can use to find out. When your graph cuts the y-axis once, just know it's a function. In this case here, we can use that method to determine whether it's a function or relation. So the answer is yes, because this graph of ours cuts our y-axis once. If it cuts more than once, just know it's no longer a function, it is a relation. Okay, people, we are done with question 2.2. I hope you guys managed to understand. Do not forget to like, share, comment, subscribe to the channel if you haven't subscribed. If you got confused somewhere, rewatch at the point where you got confused or leave a comment on the comment section. Let's go and do question 2.3. All right, guys, here is our 2.3. Now, 2.3, it has two questions, which is 2.3.1 and 2.3.2. Let's start with 2.3.1. Then, the one asked to sketch the graph of y is equal to 2 log x to the base of 1 over 3. Now, this here, clearly we can see this is a log graph. Again, log graph is one of the graphs that you can draw using a table. I prefer that you use a table to draw this graph. Now, if you use a table, there are a few things that you need to pay attention to. First, let's start by creating the table. All right. So when you draw the log graph, here are the things that you need to know, especially when you use a table. You need to know that x, it cannot be equaling to 0, and also x cannot be less than 0. So x cannot be equaling to or less than 0. That is not allowed. So whatever you're going to insert here, do not insert 0 or any number that is less than 0 for x. So we're going to insert 0, 5, 1, 1, 5, and 2. I think these here, they are enough for us to actually draw our graph. Again, guys, this is optional. So my multiplication here is 0, 5. Some of you can use 0, 0,3, 0, 0,2. It really doesn't matter, guys. As long as one of the numbers here is less than 1. Right, so let's continue. Now if we use our calculator here, when x is 0 comma 5, what is our y? So what I'm getting here is 1 comma 3 there. Right, now let's move to the next point. When x is actually 1, what is our y there? This is going to give us 0. There we go. Now when x is actually 1 comma 5, what is our y there? I'm actually getting negative 0 comma 7. There we go. And then the last one there, when x is actually 2, what is our y there? I'm actually getting negative 1 comma 3 there. So guys, this is how you're supposed to do the table when it comes to log graph. Now let's draw our Cartesian plane, and we can able to draw our graph here. All right, so here is our Cartesian plane here. So all you have to do is to plot this graph using the points here. Let's start with this point here. When x is 0 comma 5, our y is 1 comma 3. So 0 comma 5 for x is this point here. So we draw a line there that is going upwards, and then our y is actually 1 comma 3. 1 comma 3, if you look at the y-axis, should be between 1 and 1 comma 5. So this is in the middle, so we draw a line that goes this way. That is going to be our point there. Now let's move to the next point. When our x is 1, our y is 0. So this is the point here. Our x is going to be 1 there, but our y is 0 on the x-axis. Now let's move to this point here. When our x is 1 comma 5, our y is negative 0 comma 7. So 1 comma 5 is here. You take a ruler, draw the line there. Our y is negative 0 comma 7. Negative 0 comma 7, if you can see on the y-axis, it's supposed to be in the middle between negative 0 comma 5 and negative 1. So if I take a ruler, draw a line like this, and there is our point there. And then the last point, it goes like this. When our x is 2, our y is going to give us negative 1 comma 3. Now negative 1 comma 3, it's also between negative 1 and negative 1 comma 5. So we draw the line here, it goes this way, and then we draw a line from 2 on the x-axis where they meet. That is going to be our point. Then you start drawing your graph. So your graph is going to look like this. There we go. So this is our graph for this function here. Just in case, guys, you do not know, make sure that you know how to draw the shape. It doesn't really have to be a table like this. If you know how to draw this graph without using a table, it's also fine. Just make sure that the shape is fine, and also this intercept is there. So I'm going to show it 1 and 0. These are marks for that. In this case, we can leave it like this because we can see it's intercepting at 1 for x. And then you label the graph there, right? Y is equaling to 2 log x base 1 over 3. There we go. So this here, guys, is our graph. It's how it's supposed to look like. I hope you guys managed to understand this, because this really was not that difficult. It's just that sometimes when it comes to log, people forget this condition there. When you draw the log graph, guys, make sure that you do not have negative or 0 on your x interest there. X should be greater than 0, shall not be less than 0 or equaling to 0. All right, guys, let's look at question 2.3.2. Now the question goes like this. What is the range of y is equaling to 2 log x base 1 over 3? All right, guys, when they're asking for range, they're asking for the values of y at which our graph starts and where it ends. If you look here on the y-axis, guys, we can see that it does not have the ending or the beginning of this graph here. It goes forever when you look at the positive side of y, and also it goes forever when you look at the negative side of y. So you can say y is greater or equaling to negative infinity, and y is less than or equaling to positive infinity. So this is how you write this question here. 2.3.2. Guys, I hope you managed to understand this one here, because it was not really that difficult. Just in case you didn't understand, guys, you can rewatch at the point where you got lost. And if that doesn't help, you can always leave a comment in the comment section. I'll try to help you to my level best. Guys, we are done with 2.3. Do not forget to like, subscribe, comment as well if this question helped you to understand this type of questions here. Let's go and do 2.4. All right, guys, let's look at question 2.4. Now, question 2.4, it has two questions as well. It is 2.4.1 and 2.4.2. Now, we're going to start with 2.4.1. Then they want us to sketch the inverse of y is equaling to root 25 minus x squared. Now, this here, guys, is a semicircle, but they want us to draw the inverse graph of the semicircle. It is not that difficult, guys. All you have to do here in order for you to draw the inverse graph of this function is just swap your x and y, meaning where there is x you substitute with y, where there is y you substitute with x. So let's do it. So this is equaling to y, so instead of writing y, we're going to write x there, and then we have the root. Underneath the root there we have 25, right, minus. Now this is x squared. Instead of x squared, we're going to write y squared. So this is the inverse graph of that there. Now, in order for us to draw it, we need to find our radius. Remember, this here is actually from x is equaling to r squared minus y squared. There we go. So we know that r squared is actually 25. And then in order for us to find r, we have to root both sides. We know that r is going to be 5. So our radius here is going to be 5. So this graph is very simple, guys. Let me draw the Cartesian plane and then we plot the graph. All right. So here is our Cartesian plane. Remember, we are drawing this graph here. Now, before you draw this graph, remember this is a semicircle. Now, this semicircle is actually the one that is intersecting at x. How do we know? First of all, is equaling to x. Now, which side of x does this semicircle gonna intersect? It's gonna intersect on the positive side of x, because this here it's positive. Just in case you did not know, so it's gonna intersect at positive 5 on y-axis, and also it's gonna cut at positive 5 on x-axis, and then it's also gonna cut negative 5 on y-axis. So when you draw this graph, this is how it's supposed to look like. So this here is our graph for the inverse here, which is x is equaling to root of 25 minus y squared. There we go. So this graph here is the one that they wanted us to draw them. Okay, I hope you guys understand this. If you don't understand, again, go to the point where you got lost and rewatch that point. And if that doesn't help, leave a comment. I'll try to help you to my level best. Right, if it helps though, don't forget to like, subscribe, and share the videos. Let's look at 2.4.2. Now here they want us to find what is the domain of this inverse graph here. So the domain, guys, is based on the x-axis. If they ask you about the domain, just know they want you to tell us where does the graph start and where does it end on the x-axis. If you look at our graph there, I'm going to use green. Our graph starts from here. At this point, when you look at x, that is 0, right? And where else do our graph ends? It ends there at positive 5. So now if you write your domain, let me just write it here. X is actually greater or equaling to 0, but less than or equaling to 5. So here is our domain, guys. You can write it like this. It's all good. Guys, I hope you managed to understand how to do this one. This is how you do this type of equation. If it so happen that you don't understand, do not forget to watch at the point where you got lost, and also you can leave a comment on the comment section if that doesn't help. But if this help you to understand, guys, don't forget to like, share, comment, and subscribe to the channel if you haven't subscribed. We are done with question 2 of this question paper. We'll do question 3 on the next video. Thank you very much, guys, for watching. Till next time. Cheers.